All right, now we're going to put it all together and you are going to be able to make some pretty cool graphs. All right, so here's what we're going to do. We're going to bring together all the things we've been practicing in this section. First, we find the x-intercepts of a function by setting the numerator equal to 0. Then we find the y-intercepts by evaluating f of 0. Then we find any horizontal or slant asymptotes. Then we find any vertical asymptotes or removable discontinuities. And then we evaluate points as we need to find the shape of the graph. Okay, so let's practice. What if we had this rational function and we wanted to graph it? Okay, so first let's find y-intercepts. So those are going to happen when x is 0. So f of 0 is going to be 1 squared times negative 3 over 3 squared times negative 2. So that's going to be at negative 3 over negative 18, or at positive 1/6. I do that right? I hope. All right, how about x-intercepts? They happen where the numerator is 0. So we can see this is already factored for us, which is very nice. This is going to happen at x equals negative 1 and at x equals 3. So actually, let's start making our graph here. 1, 2, 3, 4, 5, 6. So your graphs don't have to be super perfect, right? We're going for, if we wanted perfect, we'll just go into Desmos, right? We're getting a rough idea of what this could look like. All right, so our x-intercepts happen at negative 1 and at 3, and our y-intercept happens at 1/6, so right here. All right, how about at vertical asymptotes? They happen where the denominator is 0. So at negative 3 and at 2. And I guess I didn't check. Do we have any of them removable discontinuities? No, right? We can't simplify this at all. So we really will have vertical asymptotes at x equals negative 3 and x equals 2. How about horizontal asymptotes? Well, let's see. We have, if we multiplied this all out, this would be degree 3 and this would be degree 3. All right, so horizontal asymptote is going to happen at the coefficient, at the ratio of the coefficients of the leading, at the ratio of the leading coefficients. Do we have to multiply all this out to figure out what those are going to be? No, if we multiplied it out, the leading coefficient of this is going to be 1, right? Because we don't have anything in front of any of these x's, and this is going to be 1. So we're going to have a horizontal asymptote at 1. Okay, so this is starting to look like something we could connect, right? Maybe we want, so we know that this, maybe we want to just plug in some values, right? Let's look at these. So between the vertical asymptotes is kind of like 3 sections. We have things happening here, things happening here, things happening here. Let's maybe plug in 1. What's f of 1? It's going to be 2 squared times negative 2 over 4 squared times negative 1. So what's that going to be? 8 over negative 16. So, or negative 8 over negative 16. So this is going to be at like a half. So we could plug in some other points, right? But the main idea is it's going to look like that. And over here, we already have this function here, so we know it's going to look like that. And how about over here, if we plug in negative 3, so let's see, negative 3 plus 1 would be negative 2 squared, negative 6 over, oh wait, not negative 3. Negative 3 is a vertical asymptote. Don't do that. How about negative 4? F of negative 4 is going to be negative 3 squared times negative 7 over negative 1 squared over negative 6. So we just kind of want to know if this is big or little or negative or positive. So this is going to be negative 63 over negative 6, so positive 9 actually is a value. So somewhere up here. So what does that tell us? It tells us the graph is going to look something like that. Okay, because we know it's going to get close to this horizontal asymptote, and this tells us it's going up, right? As x approaches negative 3 from the left, it's going to approach positive infinity. Okay, so what did we do? We found the x and y intercepts, we found vertical asymptotes, horizontal asymptote, and then we plugged in a few points to kind of get the rough shape of the graph. Okay, let's try another one. Let's do this one. F of x equals x plus 2, x minus 3 over x plus 1 squared times x minus 2. All right, so let's find x-intercepts. X-intercepts happen when the numerator is 0. So that's going to be at x equals negative 2 and x equals 3. Right? Those two values are going to make the numerator equal 0, which will make the whole function equal 0, which means the y value is going to be 0, right? That's the x-intercepts. How about the y-intercepts? They happen when x at f of 0. So that's going to be 2 times negative 3 over 1 squared times negative 2. So that's negative 6 over negative 2. So that's going to happen at 3. Okay, that's a nice, pleasant number. How about vertical asymptotes? They're going to happen when the denominator is 0. I'm looking at these factors, and it doesn't look like any are going to cancel out to give us removable discontinuities. So they're going to happen at x equals negative 1 and x equals 2. Horizontal asymptotes. Well, let's see the degrees. Degree of this is 2, and if we multiply this out, the degree would be 3. So the denominator has a greater degree than the numerator. So that means that that's going to happen at y equals 0, at the x-axis. Okay, let's put this together. Let's put it on a graph and see if anything nice happens. I guess something nice doesn't have to happen. We just are going to get an emerging picture. All right, so x-intercepts happen at negative 2 and at 3. Y-intercepts happen at 3. Vertical asymptotes happen at negative 1 and 2. And a horizontal asymptote happens here. Okay. Wonder if this goes up or if this goes down. What happens at 1? Let's just plug that in. We're going to get, at f of 1, we're going to get 3 times negative 2 over 2 squared times negative 1. So that's going to be negative 6 over negative 4. So it's going to be negative 6 over negative 4, so 3 halves. Okay, so it seems like this is going to be, and we could plug in negative 1/2 to see. I think this one's going to go down on this side, and negative 1/2 is going to be kind of messy. Can I cheat? I'm going to cheat. I won't show you what it looks like. Oh, it's going to go up. Ah. Okay, we could plug in negative 1/2. You could also cheat. Oh wait, it's going to go up over there too. Did I do that wrong? Oh, this is actually going up. So this actually goes like this. So we'd have to plug in a few more points than I was willing to do, okay, to actually get accurate behavior, right, for this going up on these sides. And how about, we'd have to plug in a point here and a point here into our function, right? And let me cheat again. Yeah, so this is going to go, if we plugged in this point here, we're going to get something up here. So this looks like, and here's something interesting. This graph actually looks like this. So we have a horizontal asymptote. Let me get rid of this distracting thing. We have a horizontal asymptote, but the graph actually crosses that horizontal asymptote. Okay, you don't have to know that from this. I'm just telling you. That's what the graph looks like. It's okay inside here for it to cross horizontal asymptotes. The horizontal asymptotes just tell us the end behavior, right? And this one is going to look like that. Okay, it's actually going to cross also and approach the y asymptote, even though it crosses here in close to the origin. Okay, so the asymptotes just tell us the end behavior. Okay, so this is the graph I was looking at that's in your book that I was cheating from. The function looks like this. Okay, a little bit nicer than mine. So yeah, this is a little bit tricky. The vertical and horizontal asymptotes give us some good ideas, but we do have to plug in a few points to really get an idea of what's happening close to those asymptotes. And I was a little bit lazy there. Okay, what if instead of having the function and figuring out the graph, what if we have the graph and they ask us to find the equation? Sorry, I meant equation before. Let's see if we can write the equation from this graph. Okay, well, we're going to have something of the form A, some constant, and then we're going to have some factors. Right? What factors can we tell already? Well, we're going to have at x equals 2, we're going to have a vertical asymptote. So I'm going to write x minus 2 down there. And we have a vertical asymptote at -1, so I'm going to write an x plus 1 there. How about horizontal asymptotes? Horizontal, it looks like the y-axis. So the degree of the numerator and denominator are going to be the same. How about x-intercepts? They are going to happen at 3 and -2. So that's where the numerator is 0. So I'm going to write x minus 3 and x plus 2 in the numerator, right? And that accounts for our x-intercepts, our vertical asymptotes, our horizontal asymptote would work out, right? Because we have the same degree. So it's going to happen, oh, sorry. If they have, we need 1 degree greater in the denominator, right? So one of these is going to be squared. How did they figure out that it was x minus 2? So here it's going to be squared because we need this denominator to be 1 degree to be greater than the degree of the numerator. I think it's the fact that both of these are going down. Yeah, that's what's happening. Both of these are going down. So that looks kind of like 1 over x squared behavior, right? Around that, because the vertical asymptotes for x squared that we looked at before both go up or both go down, right? So if both sides around this asymptote go down, it's going to have that similar behavior. Okay, so it's going to be like that. So x minus 2 squared, because they both go down by that asymptote, is going to have degree 2, and because one goes up and one goes down around x plus 1, the behavior, this vertical asymptote just has degree 1. Okay, how can we solve for A? Well, we've got one more point that's pretty easy to find. We have this y-intercept, right? When x is 0, y is -2. So f of 0 equals 2, -3, -2 squared, 1. This whole thing is going, right? This is f of 0 equals 2. Okay, so let's solve this. Negative 2 equals negative 6 over 4 times a. All right, so let's solve for a. We get negative 8 over negative 6 equals a, and that's going to be 4/3. Okay, so our original function is going to look like 4 times x plus 2 times x minus 3 over 3 times x minus 2 squared times x plus 1. Okay. Are you ever going to need to do this very often in real life? Probably not. You're probably not going to have a graph of a rational function and need to create an equation by hand that matches it. Okay. However, it does bring together all kinds of, it's similar to this, right? Are you going to graph a rational function by hand? You are not. You're going to put it into Desmos. Okay. However, it is kind of cool to look at this function and realize that you could get a rough sketch of what the graph looks like. Okay. The important things are being able to recognize the intercepts, the asymptotes, to be able to recognize what is it about this function that makes it have vertical asymptotes at those points, or to have x-intercepts at the points that it does. Okay, so doing these from a function, graphing a complicated graph, from a graph, writing a complicated function, it's kind of just like a puzzle. It's a little bit fun, but it brings together all those skills. Okay, so outside of this class, you're probably not going to have to do that very often, but you are going to be able to have the skills of looking at a function and breaking it apart to get the important features of it. Okay, so that's really what we're getting at here. All right.